Hi everyone, just making a video on the first lesson for Maths for week 9. I've decided to try and do a video and see how that works for those of you that are unable to come to school this week and probably next week. So I felt that maybe you might find it easier to have me talk through the lesson rather than just trying to read through it and understand it yourself. If you feel that you prefer just to read my notes, go for it, no problems at all. But if you think you'll learn better by listening to me or you just miss my voice, then watch the video. While watching the video, I will be expecting you to copy down the notes into your notebook and all the examples so you have it there as reference for when you do questions. Remember, it's a video, so if it's going too fast, pause the video, write down the notes, and then restart it again. So let's get started. We are going on to radicals and surds. So a radical is a number that is written using the radical sign. Now previously, you've probably known that as the square root sign, which was actually incorrect. The proper term is the radical sign. So radical numbers may be rational or irrational. An irrational radical is called a surd. So that's like, for example, the square root of 2, because we can't solve that. So it's an irrational number, it's a never-ending decimal, and we give that the name of a surd. When we have the square root of something, so like the square root of a, this is real only if a is greater than or equal to 0, because remember we can't find the square root of a negative number, so a has to be positive or 0. If we have the square root of a times the square root of a, that just equals a, and the square root of a can also be written as a to the power of a half. So the cube root is when we have a little 3, the radical sign, and the a. Now that 3 isn't a big 3, so it's not 3 times the square root of a, it's a little 3 and it means the cube root. So if we have the cube root of a all to the power of 3, that will just equal a. And with that, if a is greater than 0, then the cube root of a is also greater than 0, and if a is less than 0, then the cube root of a will also be less than 0. Then we have two rules that will help us simplify. So if we have the square root of a times the square root of b, that will equal the square root of a times b. And if we have the square root of a divided by the square root of b, that will equal the square root of a over b. These two formulas will just help when simplifying terms, as you'll see with this example. So in this example, we have 8 different examples to do. So the first one, part A, we've got the square root of 5 all squared. So with this one, you can just write the answer because as we said before, if we square root two numbers, the same number, we will just get the number itself. For those that may need a little bit more understanding, I'm going to do this example with a couple of steps and then you'll see how it works. But as I said, in an exam situation, just write the answer. So what we would get here is we have the square root of 5 all squared. So we have this equals the square root of 5 times the square root of 5. Now, if we use this simplifying rule, this one here that I'm just underlining, all right, that would equal the square root of 5 times 5, which is 25, and the square root of 25 is just 5. So you see, when we multiply the square root of a number by itself, we just get that number. Now, B, we've got 1 over the square root of 5. Now, with this one, it's in the brackets, so remember we have to apply that square to everything in the brackets. So we'll end up with 1 squared over root 5 all squared. And obviously 1 squared is 1, root 5 squared, we just worked that out, is 5. So that will just give us a fifth. Now part C, we've got 2 root 5 all cubed. Now remember, anything in the brackets, when there's a power outside it, has to apply to everything inside. So this would be 2 cubed, and then we'd have root 5 all cubed. Now with this one slightly different, we have to be careful with the cubed. So 2 cubed, which is 8. Then we've got root 5 cubed. So we're going to have root 5 3 times. Okay, now this next step, we've got 8 again, so I'm just going to leave the 8 for now, 8 times. We know if we just focus on 2 of them, so root 5 and root 5, that will just be 5. We know that from the last 2 questions. And we've still got 1 root 5 left. So if we work this out, we're then going to end up with 8 times 5 is 40, and root 5. And we just leave our answer like that. We don't convert it to decimal form. With this booklet, we'll pretty much be leaving all our answers as surds. Alright, part D. This one we've got negative 2 root 5 times 3 root 5. Now negative 2 root 5 is the same as saying negative 2 times root 5, and 3 root 5 is 3 times root 5. So for this, because they're all timesing, we can just write them in any order. So what I'm going to do is, to maybe make it easier, I'm going to multiply together my terms that are similar. So I'm just rewriting the sum then. So negative 2 times 3 times root 5 times root 5. And negative 2 times 3 will be negative 6. And root 5 times root 5 we know is just 5. And so that will give us negative 30. E. So E, we're going to start using those two last rules we wrote down. So root 3 times root 2. We can combine that under one square root as the square root of 3 times 2, which will just be the square root of 6. Can't solve the square root of 6, so we just leave it as is. F, same idea as in part D. We'll just times together the like sections. So we'll have 2 times 3, which is 6, root 5 times root 2 under the square root, which will give us 6 root 10. And once again, we can't solve the square root of 10, so we just leave it as it is. G, we're going to do some division. Root 32 over root 2 looks horrible, but you'll see when we work it out with the simplifying rules, it becomes a nice lovely number. So what we're going to do first is rewrite this all under one square root. So the square root of 32 divided by 2, which will give us the square root of 16, which is just 4. So sometimes things with radicals and surds can look horrible, but when we actually work it out and simplify, it becomes a nice lovely number. And the last one. So with this one, there's different ways you can work it out. I'm going to do it 2 different ways, and then you can just choose which you would prefer. So the first way I'm going to do it, we've got root 12 divided by 2 root 3. So what I'm actually going to do with this first time is I'm going to change that 2 to a square root itself. So 2 would be the square root of 4. Okay, so I haven't changed the number, I've just written it a different way. And that's still going to be times the square root of 3. Now if we look at simplifying this then, we're going to get the square root of 12 over the square root of 12, which will just simplify down to 1. Another option to do this, which is a bit longer, but depending on the numbers, it could be nicer. That divide by 2. Okay, if we could think about that as that's a 1 in front of the square root of 12, so we've actually got a half there. So we can actually change this to look like this. So we can say equals a half times root 12 over root 3. Now we can simplify it from here. So we're still going to have a half, and the root 12 over root 3 will become the square root of 12 over 3, which means we will end up with a half times the square root of 4, which is a half times 2, which equals 1. Still get the same answer. As I said, bit of a longer process, but if you end up with really big numbers, it's sometimes actually a bit of a nicer way than making one surd, especially if you are in a non-calculator paper. That is all I wanted to go through for this lesson. So in your workbooks now, I would like you to do exercise 4A and email me if you have any questions or you're not sure about anything, and then I can get back to you.